And now we are going to start defining our roof geometry. But before we jump into our Grasshopper definition again, we are going to explain very quickly what possibilities we have in Grasshopper to define surface geometries. So in order to do that, I'm just going to Rhino to the top view, and I'm going to define a surface here out of a curve, let's say. So I'm going to use this polyline, and I'm going to define this area here, okay, like that, and I'm going to copy it to the left side. So if I hit and hold the Alt key in our keyboard, we can actually copy curves or any other element in Rhino, like that. So let me exit our Grasshopper definition for 1 second. And what we are going to do is to create a surface out of these curves. So for that, of course, we have to start by referencing our curve geometries from Rhino. Let's start with this in the left side, like that. And if we want to create a surface element, we have two approaches. The first approach is to use Grasshopper surfaces. So for that, we have to come to this surface category, and of course there are many possibilities to do that, but a very simple one is to use the boundary surfaces component, like that. So now we just have to provide this component with the edges that make up the surface, and then it automatically creates a surface, like that. So you can see that a surface is actually a continuous element, and in this case it is a planar surface, a very simple one, but it could get very more complicated. And since this is a continuous element, what we can do is to explore it using the surface domain. So if you remember, when we were dealing with curves, we used this evaluate curve component, in which we could get a certain point from the curve based on the point parameter. So we have actually a very similar option for surfaces, but now what we have to do is to use the evaluate surface component, like that. So this works very similarly. First, we have to plug the surface, of course, we want to extract points from, and now we have to specify the point parameter. So there are actually two approaches for that as well. In Grasshopper there are different possibilities for everything, but I think the most intuitive one is to use a certain slider for that. But this is a very special slider that you can find under the parameter tab under input, and it is the MD slider, this guy here. So we are going to get it into the canvas, and now you can see that this is actually some kind of a slider, of course, in which we can select values that range from 0, 0 to 1, 1. But you can see that it has actually 2 dimensions, because surfaces, if you leave the mouse here, you can see that they have 2 coordinates, U and V, unlike curves which had just 1 parameter. So let's plug this slider here to see what happens, and now you can see in Rhino that we are selecting 1 point of this surface, but we are just selecting this area here, and what is happening, it is basically the same like with curves, that the domain goes actually between 0 and in this case the length of each side of the surface, let's say. But what we can do is to reparameterize our surface, like here, by making right click into this input surface, of course, and then clicking reparameterize. And now the domain goes between 0 and 1. So as you can see, these are the UV coordinates, or coordinates which are more or less perpendicular to each other. We are varying the U value and we are keeping V as 0, so you can see how we are moving along the edge. And now we can do the same, keeping U constant and varying V, and you can see how we move in this direction. And we can even try to do it, of course, with a constant value of U, different from 0 and 1, and you can see how we can move our point along one of the 2 coordinates, U or V. So this is basically how surfaces work in Grasshopper. But as I said before, we have another possibility to define, let's say, surface geometries, which is using meshes actually. So in order to explore what meshes are, you can come to this mesh tab here, and you have a lot of possibilities here. So of course, if you have used the finite element method before, you already know what a mesh is, but let's define one in Grasshopper. So let me get some auxiliary components for that. Of course, let's start by referencing the curve here. And in order to create our mesh, we need a set of points before, which I'm going to, get from this component here, populate2d. Now we have to specify the region. I'm going a bit fast because this is an auxiliary explanation. We don't need that. This for our parametric truss structure. So this is the rectangle, and let's specify the domain of our rectangle, which is going to be between 0 and probably 0 and 9. That's right. And now let's select just points inside of this curve. And for that, okay, this is interesting. For that, we are going to use a conditional in Grasshopper for the first time, which is going to be point in curve. So, because what we want to do is to select the points that are just inside of this curve. So, what we are going to do, of course, is to get the curve and get the points that we want to check if they belong to this curve or not, or if they are inside of it, better said. So now the output of this component is values between 0 and 2. So 0 if it is outside, 1 coincident, and 2 inside, as you can see. But to make it more simple, let's transform this output into a boolean. So now you can see that any value other than 0 is true, and any value which is 0 is false. Okay, so now we have these values here of true or false, which that make reference to the points that belong to this surface or not. And now what we have to do is just to remove the points that are out of this boundary, or better said, the points with a false value. So in order to do that, what we can do, and we already used this component before, is to use the call pattern component. So we have to come back to the set category, select the call pattern component like that again. So now the list is our list of points, and we already have the pattern here, so we don't have to define it from scratch. And now you can see how we are just preserving the points that are inside of this surface. Okay, so this was basically an auxiliary explanation, but this combination of a conditional and this call pattern component is very interesting in Grasshopper, and I actually use it like all the time. So now, finally, we can define our mesh, for instance, with this mesh component. Why not? So these are my points, and this is the mesh that Grasshopper is creating. So let me hide the other guys here. Okay, so you can see that unlike surfaces, a mesh is made up of discrete elements, in this case discrete faces. So actually what we can do is to use the deconstruct mesh component, and we can see that a mesh is made up of vertices, which are the points here, and faces. And a face is, like I said, a discrete element that is defined by the points that define its boundary, as you can see here. So for instance, the first face could be defined by the points with index 22, 17, and 27. So you have now these two possibilities here to define surface geometries in Grasshopper, which are surfaces, as the name says, and mesh geometries as well. So a surface is a continuous element, and a mesh is made up of discrete elements. These are basically the biggest differences. And now let's actually start defining our roof geometry. And for that, we are going to go on with our surface. So we are going to use a surface instead of a mesh, because we are going to use this domain property to define the trusses that are going to be supporting this roof. So let me delete these guys and get back to our Grasshopper definition. And let's get back to the 3D mode in Rhino as well. And we are going to delete this curve because we don't need it anymore. So now what we have to do is to define a set of lines here in this roof that are going to serve as baselines for our trusses. So instead of using a baseline like we did before, which was defined by 2 points, now we have to define them from this surface here. And so let's hide this guy here and let's start defining our baselines. Okay, so this is our roof, and let's define the baselines. And for that, there is a component very interesting that we can use. That is the isocurve component, which we can find under the curve category and the spline subcategory right here. So now we just have to provide a surface to this input parameter, and we have to define our coordinates as we were doing before. So for that, we can use a MD slider. But the thing is that if we use this, okay, we are getting the isocurves here, which is very interesting and so on, and we can even reparameterize our structure to get to cover the whole area. But it's not very useful for us in this case because we would have to select manually all our baselines. But anyway, you can see that this component is a very interesting approach because we are getting curves that cover the whole surface, let's say. But what we need to do is to find another way of specifying these coordinates so we can automatically select multiple values at the same time. So there is actually another approach for that, which is, and this is very interesting, which is to use the construct point component. So if we get back to this vector category and the point subcategory in our components panel, we can use the construct point here, and let me define the coordinates between 0 and 1 with a slider, actually with 2 sliders. So now we are going to connect this guy here, and you can see, how we can actually select the point parameter in the surface with normal sliders through this construct point component, which is actually a bit, it's not very intuitive, but this is very another interesting way. So what we are going to do, and of course this could be the x coordinate, could be the u coordinate for our surface, and the y coordinate could be the v coordinate. So what we're going to do is now to select different baselines in our surface based from these, which are coming from this component here. So basically we have to select several values from this for this x coordinate, or if you wanted to do it in the perpendicular direction for the y coordinate. But anyway, we have to select several values for this input that are equally spaced between each other. So how can we define multiple values at the same time? So this is very interesting in Grasshopper as well, and for that we are going to use the range component like that. And if you are interested, of course, this is under the set tab, under sequence right here. So our range, you can see that it requires a domain, which is actually the extreme values of this range of values that we are going to get, and the steps. So in this case, the domain is between 0 and 1, and there are 10 steps, which means that we are going to get 11 values, so one more than the number of steps that are between 0 and 1. But the important thing is that these values are equally spaced among each other, so 0, 0.1, and so on and so forth. So this is very interesting because the values goes between 0 and 1. Of course, we could specify another domain, but this is actually what we are looking for. So let's see what happens if we connect this range component here. And now you can see that we are getting actually the baselines that we are looking for, because they are more or less parallel to each other, and the spacing between each curve is the same in every case. But of course, it would be very interesting if we could actually specify how many baselines or how many trusses we are going to have for our roof structure. So for that, we just have to define a slider to control this steps parameter. So let's define a slider between, of course, between 2 and, let's say, no, actually, if we want 2 values as the minimum amount of lines, we have to say 1 step. And the maximum value is going to be, I don't know, for instance, 9. So now you can see that we get just these two baselines. And actually, because we are interested in these curves here, so, and if we increase the number of steps, you can see how we increase the number of baselines in our roof structure. So we are going to leave it like that. That's right. And now what we are going to do is to actually, let me flatten this output here, and we are going to see what this means in just 1 minute with three structures. I'm sorry. But now let me use this. What we have to do, of course, is to replace our baseline for our truss structure that we had here with the new baselines that we have just defined in our roof. So let's get these curves here and let's connect them like that. Okay, so this is very interesting because now we are getting our our trusses in this roof. But if you remember, we started using the baseline for the lower chord. We just have to move this surface in the vertical direction, so it is located in the same point as our upper chord. So let's get this guy. And we have actually to get the same vector as we were using here. So now you can see how the surface is located in that point, so in the right height, I mean, and we can hide these input parameters, and yeah, you can see how now everything makes much more sense. And you can notice that now our lines have become this kind of dashed lines, which means that now we are going to be dealing with three structures, and we are going to see that in just 1 second.